All right, so now that we've done some work with some square roots and some squares, we're going to dig into some review of the triangle sum theorem. And as you can see, there are 5 triangles on your sheet. If you want to go ahead and name those 1, 2, 3, 4, and 5, what I'd like you to do is find the sum of the angles in each triangle. And go ahead and pause the video and do that. When you're finished, restart it. All right, so this is kind of the way this needs to look. Recall the concept of sum is that we are adding things together. So you can see here on this triangle number 1, we have the value of 25, we have the value of 115, the value of 40 in each of the 3 angles. We're going to add those 3 together and come up with 180 degrees. In addition, number 2, we've got the value of 50, the value of 65, the value of 65. We add those guys together to come up with 180. And fortunately, for 3, 4, and 5, we are going to come up with the same exact thing, which brings us to the formal definition of the triangle sum theorem. And on the back of your page, you'll see the question, what is the triangle sum theorem? And I want to go ahead and jot this down. It is the sum of the angles in any triangle is equal to 180 degrees. That should be an 8. So yeah, 180 degrees, always, always, always. So jot it down and pause the video rather and restart it when you're ready. So now let's take some time to put that tool to use. We've got a triangle over here on the right hand side and we have a question. How can you find the measure of angle 1 in triangle JLK? So first of all, let's focus on what angle we're looking for. We're looking for the measure of this angle, right? They've named them by numbers. And we're talking about a triangle JLK. So we're going from J to L to K and then back to J, and I have highlighted the triangle that is in play. So the question is, again, we're looking for the value of this, and if we were to try to use the triangle sum theorem here, we would need at least 2 of the values of the angles in order to come up with the third one, but we don't have that, right? We've got a 28-degree angle here in this little corner. We've got a angle named angle 3 here, and then we have angle 1. So the triangle sum theorem unfortunately isn't going to help us here, but what they've done is they've created this, they've got this large triangle and they've got these 2 guys in the middle, right, created by line segment LK, and what we have going on between this angle 1 and this angle, this guy is 57 degrees, if you'll recall from the first semester, is we have a linear pair. And remember, a linear pair is always worth 180 degrees. The sum of the 2 angles that form a linear pair will be 180 degrees, or they're supplements of each other. They're supplementary. So I can kind of look at it like this. The measure of angle 1 plus 57 is equal to 180 degrees. Or if you're going back to the first semester, once you got pretty good at this, you know that if you just take 180 minus the angle given, that will give you the value of the measure of angle 1. And this is just a little algebra I did some to get to this point. You put that in your calculator and you're going to come up with 123 degrees. All right, so now that we have the measure of angle 1, let's go ahead and write that in, because that is going to become helpful for our next question, which is over here. So question number 2, how can you find the measure of angle 3 in triangle KJL? All right, well, let's highlight the triangle let's highlight angle 3 first. So this is the angle we're looking for, the measure of this angle. And they're telling us it's in triangle KJL. K to J to L. Now look at that. Same exact triangle, but they named it 2 different ways. It doesn't matter to me how it's named in this case, right? The only time the letters really come into play when there's a certain order is if we are working with congruency or similarity. But we aren't here, so it doesn't matter. However, we do, in this case, have a triangle. We have the value of 2 angles in the triangle. So here is a place we can use the triangle sum theorem. And one of the things you'll hear Mrs. Thompson and I say, if you have 2 angles in any triangle, then you're going to do this. You're going to do 180, the total value, minus, right? 180 minus minus gets you the leftover stuff. In this case, the measure of angle 3. Same concept, right? The triangle sum theorem says 123 plus 28 plus the measure of angle 3 is equal to 180. We just sort of did the algebra in advance. When I do this in my calculator, I'm going to come up with 29 degrees. All right, so our final question inside this triangle, or relating to this triangle, is how can you find the measure of angle 2 in triangle LKM? So let's focus on angle 2. This is the angle we're looking for, the measure of that angle. And we can highlight the triangle we are focused on, or what they told us about. Oops, didn't grab the highlighter like I meant to. Okay, so we're going from L to K to M. Now, we have a whole bunch of other information over here, right? We know this guy's 123, we know this guy's 29, and maybe it would help us depending on what other information was provided, but I know immediately, because this little triangle serves its purpose just like any other triangle, that I have the same process I'm going to use as I did up here. I'm going to take the 180 degrees, which is the value of the sum of all of them. Whoop, back to my highlighter. All right, we've got 180 degrees, the total, and I'm going to minus this just like I did above to come up with the missing value. So I've got 180 minus 57 minus 71 is equal to the measure of angle 2. And in the calculator it goes, and I'll end up with 52 degrees. And we are down to our other example. And in this case, the question is, find the value of x in the triangle to the right. So in this triangle, we've been given algebraic expressions to explain what each of these angles are. And the fact that the value or the sum of these three angles will be 180, I'm going to use that tool. I'm going to use that definition to come up with the value of x. And the way I'm going to do that is I'm going to take the first angle, I'll do 15x plus 1, and I'm going to add all three of these expressions together. So I have 15x plus 1 plus 6x plus 5 plus 4x minus 1. The sum of those three will equal 180 degrees. So we got a little algebra to do here, right? We got some like terms. There's a 15x, there's a 6x, there's a 4x on this side of the equation, there's a 5, a 1, and over here a little negative 1. You need to combine some like terms, do a little subtraction, a little division, and that's going to get you to x. So if you could pause the video and go ahead and try to work through this algebra equation, and then check your work when you're finished and restart it. All right, so we're back, and you should have gotten the answer x equals 7. Again, we're combining our like terms. The three x's give us 25x plus 5, which is the whole numbers, equal to 180, right? This guy's still on that side of the equation. Subtract 5 from both sides. Leaves us with 25x on this side, 175 over here. Divide both sides by 25. I'm going to end up with x equals 7. If you still do not understand, just raise your hand. We'll give you a hand. If not, please move on to the next assignment.